All right. So we're going to talk about, we just got through talking about dependent and independent variables in preparation for the exam next week, um, which will be week 8 in the class. And so I sent you this thing here. Did I send this guy to you guys? Did I give you guys this? Tell you what, I will send this to you with the answers if I didn't. Somebody let me know at the end of class, okay? All right, let's see if we can figure this out together. Yeah, let's see if we can do this together, and then I'll send this to you, okay? Um, so I found that this worksheet's just really helpful. Once we go through this, people start getting it. Identify the independent and the dependent variables in the following statements. The more time people spend on social media, the less they read books. All right, what is the independent variable? Okay, the independent variable would be this one right here. It's time on social media. Okay, that's the independent variable, and it has to do with time. They don't always, but in this case, it does have time. It's independent. It's the one that's going to affect something else. Okay, what does it affect? Well, it looks like the less they read books. So, time. Okay, I could just put down again time reading books. Okay, that's the one that's affected. The more time, it makes sense. If you spend a ton of time on social media, you're probably not spending a lot of time reading books. Let's look at number 2. Drinking energy drink makes people more aggressive. Independent variable. Think about it. What's the one that kind of happens first and then it affects other things? Yeah, this is my independent. Drinking, I'm going to put down ED, which energy drinks. Okay. What does it affect? I'm going to just put down aggression. Okay. It affects people's aggression. The more energy drinks you drink, the more aggressive people are. I don't know if that's true, but anyway, I'll go on. Taking a nap in the afternoon makes people more focused the rest of the day. What's my independent variable? Okay. Nap at noon, I'll just say. That's the one. If I do that, it makes me more focused. Okay. More focused. So that's my dependent variable. It's dependent on if you take a nap, it's going to affect that. Okay. Time spent with my family dog decreases the amount of stress someone has. Well, what's my independent variable? Time with dog. That's my independent variable. Okay. What is my dependent? What does it affect? Well, if I spend time with that, my stress level, it affects my stress level. By the way, guys, they have done studies and they have found that people who spend time with their pet, their cat or their dog, it does reduce your stress levels. They have lots of studies on that. Okay. Eating breakfast in the morning increases my ability to learn at school. What's my independent morning? I'm not writing very neatly here. Breakfast. Okay. That's my independent variable. What does it affect? My ability to learn. Okay. You guys getting this? Okay. Kind of getting the idea here that your the independent variable is the one that affects the other one. All right. By the way, I'm going to send you not only the worksheet that I'm going over here, but I'm also going to send you the answers. In fact, I'll just send you one sheet that has the answers on it. But I wanted to go over this together. But you'll have the answers on this, okay? So you can kind of study. Um, let me show you some that are a little bit harder. Okay, a couple of examples that are a little bit more complex, but okay, more challenging. It says, okay, so students watch a cartoon either alone or with others, and then they rated how funny that they found the cartoon to be. Okay, I'm going to do this. Do it like this. Is that too much? All right. So yeah, they watched the cartoon either alone or with others, and then they rated how funny the cartoon was. Okay, well, think about it. What's the independent variable? It's a little harder, but it's watching cartoons alone or with others. Okay, that's my independent variable. What did it affect? How funny that the TV show was. Okay, that becomes my dependent variable. How funny it. And they actually have studies. If you watch like a good old comedy at a theater and you watch it by yourself, it's not that funny. But if there's other people in the audience, in the audience with you watching it, you tend to find things funnier. Another example: a comprehension test was given to students after they had studied textbook material either in silence or with television on. What is my independent variable? It's going to be studying in silence or with TV on. Okay, that's my independent variable. What does it affect? Probably going to affect my score on the test. Okay, that's dependent on. Okay, you got too much television in the background, you're not going to score as highly on the test, so it affects it. This is a really interesting. Some elementary school teachers were told that a child's parents were college graduates, and the other teachers were told that the child's parents had not finished high school. Then they rated the child's grades. Okay, all right. What is my independent variable? What are they doing first? Telling parents the kids, I'm sorry, they're telling the teacher, kids' parents went to college. Okay, that is my independent variable. Sounds like a weird study, but if they told them that they found in the study that if they told the teachers, hey, this kid that you got in your class this year, his parents went to college, they graduated from college, then they rated the child's grades. Okay, what they found was in this hypothetical study here, it affected the child's grades, meaning that in that case, they're saying that, hey, if the teacher thought the kid had parents that went to college, they give them better grades, thinking they must be smarter. Okay. Um, yeah, you're okay. You're okay. Yeah.
Thank you.
All right. Um, okay, I think I've done enough giving you the idea of what an independent and a dependent variable is. Okay. Now, again, this worksheet that I'm showing you here, this independent practice, I'm going to send this to you with the answers. So it'll in red, it'll have the answers here. So you can kind of study and you'll know, okay, you'll start getting it. But I found that this is the best thing I've done to teach students the difference. Okay. All right. If you guys could you all mute your microphone, which means turn it off so I can't hear it. All right. What we're going to do now is we're going to go over the exam. So we're recording right now. So we're gonna kind of go over it. This exam that I'm now showing you here, I sent this to you last week on like Friday, and I also sent it to you again this week yesterday. Okay. Additionally, it is in. Hold on. Resume recording. Okay. We're going to find the absolute values here. Okay. Remember, absolute value is how far a number is from zero. Okay. These two lines here, we learned this like last week, mean absolute value. What is the absolute value of 6? Okay. It's 6 away from 0. That would be the answer. I think I'm going to use pen here. 6. Okay. What is the absolute value of -3? Again, these two lines around a number means absolute value. All it's asking is how far is this from 0? Well, it's 3. Okay. It's 3 away from 0. Okay. Now, this is a bit of a tricky one here because it's asking you, if I covered up this first negative here and just said, what's the absolute value of -9? You just say 9. Okay. But You know what? I'm going to try something different. See if this helps. Is that better? I turn off one of the lights I have here. Maybe that's better. I don't know. Um, so, um, but it's asking for the negative absolute value of -9. So in this case, it would be just -9. Okay. Now, most of the time, they're all going to look like just right like this. There'll be nothing out in front of them. So it's just how far is it away from 0? Okay. All right. Let's look at number 5 here. I'm just going to do like the odds here. If it's 42 degrees below 0, okay, that's a minus 42 degrees. By the way, this little symbol I hear, that little circle means degrees. But the temperature will increase by 39 degrees. Okay, so it's going to go plus 39. It's going to go up by 39. Can you guys hear my dog? She's sharing with you guys. She doesn't like it getting colder, I guess. Okay. By the end of the day, what will the temperature be at the end of the day? Show the calculation and answer. Okay. When we were learning about adding opposite signs, the rule was subtract and keep the sign of the bigger number. Okay. Well, if I do 42 minus 39, just do it the old-fashioned way here and borrow 9, 10, 11, 3. What did I just do? That should be a 3 there. Yeah, 3 degrees. So it comes out with 3 left. Okay, we could do that in our head. What's the bigger sign? This is the bigger sign. Okay, so it's -3. Okay, so it would be -3 degrees. Okay, again, when you're adding opposite signs, subtract and keep the sign that's the biggest, of the bigger number. Let's look at, let's do one more, like, let's do 6. If it's 13 degrees below 0, that's minus 13 degrees. But the temperature will increase by 43 degrees. That'd be plus 43. It's not getting smaller, it's going up. What will the temperature be at noon? Well, if I subtract 13 from 43, I get 33 minus 3 is 30 equals 30 degrees. Okay, it's 30 degrees Fahrenheit. Okay. I'm subtracting this from this and keeping the sign of the bigger number, keeping the sign. And again, when you don't put a sign in front of it, it's always assumed it's positive. Okay. All right, let me go on to the next one here. It says plot each pair of numbers on the number line and then circle the larger one. Circle the larger one. It wants me to circle the larger one in the box between the numbers right, greater or less than. Okay. So this one here says this is minus 12 sevenths, which is really minus 1 5 sevenths, okay, which would be like about right here on the line here, okay. This is minus 12 over 7. And the other one is 13 over 4, which is going to be a positive. 4 goes into 13, 3 and 1/4. So it'd be about right there. Okay. This is 13 over 4. Okay. Now, which one would be greater? Well, this one here is greater. It's positive. Any positive number is always going to be greater than a negative. Okay. One more real quick. 35 over 4. Well, 4 goes into 35, if I just figured out in my head. 4 goes into that 8 and 2, 4, so 8.5. This is like 8.5. How do I know that? Because 4 goes into 35. 8 times 4 is 32. So anyway, 3 goes into 25. How many times? 8. And because 8 times 3 is 24. So there's 1 left over. It's 8 1/3. Which one's greater? 8.5 is bigger than 8 1/3. Okay. All right. Let's do some of these adding and subtracting. We already talked about when we're adding with opposite signs, we just subtract. Here's how I would do this in my head. 23 minus 10 is 13, and it's 1 less than that, so it's 14. It would just be a positive 14. Okay. Subtract and keep the sign of the bigger number. Again, here's another one. Opposites, adding opposites. Okay. If I subtract 33 minus 19, that'd be like 33, 23, 13, something, but the one less is 14. So it'd be negative 14. Okay, I'm subtracting these two numbers, and then I get an answer, and I keep the sign of the bigger number. Okay, let's do 13 here on the screen. I'm going to go a little bit lower because it'll make it bigger. All right, that's not too bad, is it? So I got minus 13 minus a minus 3. We talked about this is a double negative. A double negative becomes a positive. So this really means minus 13 plus 3. Minus 13 plus 3 equals, I'm going to wait a couple seconds. Okay, hopefully my internet's back. So now I've got opposite signs, so I just subtract 3 from 13 gives me 10. Keep the sign of the bigger number. This is the bigger number, so it's minus 10. Okay. All right. All right, let's go on to the next page because I think we've covered all the kinds of ideas going on that page. Next page, let's talk about this one. All right, let's just do like this number 17 here together. I'm going to walk you through this 17. Go from left to right, go real slow. Okay, you're going to have like 2 of these like this on your test next week. Okay, I'm going to go, I've got negative 23 plus a negative 3. When you add the same signs, you keep the sign, just add and keep the sign. So that gives me minus 26. Okay, when I do those 2 together, that gives me minus 26. Whoa, that kind of looks bad. Let me make that clearer. Okay. Now it says that next thing is 2 plus 12. Well, if I'm minus 26 and I'm adding 12 to that, I got to go, what's 26 minus 12 is 16, 14. So that's going to give me minus 14. Okay. Then it says minus 14 minus a minus 19. These 2 minuses together become a plus. So minus 14 plus 19 plus a positive 19 equals, I'm going to subtract them, and that gives me a positive 5, because 19 minus 14 is 5, and keep the sign of the greater number. Positive 5 plus a negative 9. So that's, 5 plus negative 9. When you're adding opposites, you subtract and get a 4. Keep the sign of the greater number, minus 4, okay? So that's how I would walk through all of these, 16, 17, 18, they're all the same, okay? And these are just adding with what we're calling integers here. All right, this one here, I'm just going to tell you how I would do it. I'm not going to do it all on my calculator, but you could punch this into your calculator. 23 over 4 divided by 13 over 11. You could punch it in your calculator, create a fraction first, and do the division sign, and then go over, and then divide by them. You're going to get an answer over here, okay? The answer you're going to get is going to be 4, kind of a long one, but it's 4 and 45 over 52. That's what you're going to get. Now, this is by punching it in your calculator. You might end up getting a improper fraction. You might have some big number here over 52, and you can divide it into it. Anyway, so once you get this number here, but the question is, oh, I'm dealing with integers. What's the rule when we multiply or divide and we have opposite signs? Okay, when we have opposite signs, the answer is always negative. So it's going to be a minus 4 and 45 52s. Now, here's how my brain thinks about this. Okay, I go like this. I got to multiply negative 13 over 11 times something, and my answer becomes a positive. Okay, so what do I multiply a negative by to get it to a positive? A negative times a negative is a positive. That's kind of how I figured that out. Okay, So if you're lost right now, you need to review your notes from a week or two ago when we were talking about adding integers. Okay, this is why we study for the exam. Okay, all right, we're going to go on here and do number 21 here. I've got a -9/2 divided by a -9/5. Punch it in your calculator. I got a negative divided by a negative. It's going to be a positive. Okay, it's going to be a positive answer. Okay, because a negative times a positive gives me a negative answer. All right, that's a little bit about division. If you're lost there again, you'll need to review your notes, review how to do positive and negative numbers. Okay, I'm just going to do one of these now with the multiplying here. Number 23 here. Watch how I do this. Start from the left. 4 times 3, these are positives, is 12. 12 times a -2 gives me a -24. A -24 times 5 is going to give me some big number. And then I take that answer and multiply that answer by 6. And it is going to give me, whoa, yeah, a -720. That'll be my final answer, okay? And why is this negative? Why is this -720? Because I have a -24 times a positive number will give me a minus times a positive is always a minus. I've got a minus answer I'll get here, and I'll be multiplying that again by another positive. It'll always be a minus, okay? For the fourth time, if you're lost right now and you're going, hey, you're losing me when you talk about multiplying positive and negatives, you're going to have to go back and review this, okay? Because it's just something you have to practice and let it sink in. And again, you're going to have this sheet that I'm going over right here. I will send you this with the answers as well. So you'll have the answers so you can check and see if you do it. Okay? Okay, good. Glad to hear that. All right, let's go on to a different kind of problem. So those are all kind of the same. They're all practice with that kind of concept. Now I want to talk about this concept here. Okay. So does that help right about there? Okay, you will use the table to answer 31 through 33. You have just separated your jar of beads into colors. You have listed the colors buttons that you have in the jar. All right, so you got a bunch of buttons that are colors that you put in a jar, okay? You know, like a button on your shirt, okay? And so you got this jar full of buttons, okay? All right, so there's 24 red buttons and there's 18 blue, etc. Okay, and then it asks you this obnoxious question. Find number 31 here says, find the percent for the category labeled blue, round to the nearest tenth. Okay, how would you figure out the percent? The percent. Here's how you would do this. Blue, where is the blue here? It's right here. There's 18. Okay, there are 18 blue. Okay, I'm going to just write it down here. Now, here's how you're going to figure this out. You're going to add the total all together. I assume you have a calculator. Want to do that real fast. Here, let me just do this real fast on my calculator. Okay, my TI-30XS. Okay, I got 24 plus 18 plus 15. Oops, I messed it up. 24 plus 18 plus 15 plus 9 plus 6 plus 3 equals, it comes out to 75. All right, 75. All right, to find out what percent, you remember we taught you this 2 weeks ago, when you're finding out the percent, we take the part and divide it by the whole, the total. So in my calculator, if I clear and I go 18 divided by 75, it equals 0.24. All right, to change that to a percent, that's a decimal, I move the decimal point 2 places to the right, so it's 24%. Okay, so there are the blue buttons in this jar. 24% of them in that whole jar are blue. Okay, now I'm going to go back to my original question here, and I'm going to make sure it says round your answer to the nearest tenth. And again, I'm modeling this for you. You should do this on tests when you can, when you have paper tests. Nearest tenth. In this particular case, I didn't have decimals after my, so it's just 24%. What if I had 24.65? Then I'd probably round it up to 24.7. Okay, but make sure you don't miss that. All right. Let's see. If same question, find the percent for the category labeled yellow. Labeled yellow. Here's how I would do it. I look at my thing. I got 15 yellow. Write that down. I know I have a total of 75. I would divide 75 into 15. I'd punch in my calculator. 15 divided by 75, and I'd get a decimal, turn it to percent, round to the nearest tenth. Make sure I do that. I got the answer. Okay. Now, I told you in my email on Monday, don't do number 33. It's asking you for a sector central angle. We skip that out of the book because there's a lot of reasons. But anyway, just so don't worry though. It won't be on the test. I just wanted to tell you this now because if you run into this and you go, teacher never talked about this, and you know, anyway, don't worry about it. It's not going to be on the test. All right. Oh, by the way, if you run into a question where they ask you, like on another exam, if they ask you, find the percent, you know, you got people who like baseball, people like football, hockey, golf, these are the sports they like. If they ask you for the percent of football and basketball likers, okay, they like cards for football and basketball, I would add these two numbers up, get a number, and divide it by their total. And that would give me the percent of both of these, okay? All right, so that's finding a percent. I hope that's somewhat clear. Again, number 36 is one of these, find this, the sectors angle, central angle. Don't do that one. Don't worry about it on the practice test, okay? All right, then let's get into some more graphs here, okay? Let me put this up here. From figure 1, what amount of money does the Powers family spend on transportation and insurance? Okay, so I'm going to show you how to do this. So from figure 1, I got to look at a figure. There's going to be a graph. Number 1, what amount of money do they spend on transportation and insurance? Let's look at the graph, okay? Here it is. There is figure 1. All right. So they want to know, here's transportation, okay? And it said insurance, right? So insurance is down here. All right. So but it wants to know what amount of money. So I'm going to write this down here. Money. Everybody likes money, right? All right. What's the amount of money? Okay. Here is how you're going to figure this out. All right. Remember I told you that a pie chart shows you a part compared to the whole, right? What is the whole pie? I'm going to show you here. I'm going to circle it. The family monthly budget is $4,200 per month. That's the whole pie right there. That's the amount per month. When we look at 13% for transportation and 7% for insurance here, what is 13 plus 7? It's 20%. So if I punched it in my calculator, I could do it like this. I could go, well, yeah, it wants to know how much for transportation and insurance. That adds up to 20. I could do it like this on my calculator. 0.20, which is 20%, times $4,200. Okay, I'm going to do it in my calculator real quick. On, clear, on. Okay, so that's 0.20 times 4200 equals $840. So they spend on their monthly budget $840, there's my answer, on both transportation and insurance. That's how I figured it out. So again, let me give you another example. If they ask you what percent is spent on rent, okay, this looks like a dot here, but it shouldn't be there. 32% of their budget, and there's kind of should be a kind of like a line here somewhere. I'll put it in here like this. I think it didn't copy very well. 32% of their budget is on rent. Okay, how would I figure out how much money they're spending on rent? I would go 0.32 times the total, 4,200, and that would give me the amount of money, the percent that's spent on rent. Okay, all right, let's go on to another problem. Yeah, so look at number 40 here. We'll just look at this number 40 here, right here. From figure 2. Okay, right away I'm looking at a different chart. See how the first one up here said figure 1? Different chart. How much did the Hogan's hot dog stand earn during the months of July through September if each hot dog sold for $1.85? Okay. 185 July through September. Let me show you this chart here. Okay, so I'm going to write this down. 1.85. It said per month, right? Yeah. No, it said for July through during July through September months. Then wait a second. Yeah. Yeah, $1.85. So it's July through September. All right, so we know we're talking about this one right here. Okay, so just to kind of help you understand the chart here, I'm going to really pay attention to the chart here. It says one hot dog equals five. One of these symbols of a hot dog equals 500 hot dogs. One of them represents 500 hot dogs. So like from January through March, 500, 100, 150 hot dogs were sold. Okay, so they want to know how many were sold, how much money did they make. When it's $1.85 per hot dog, here's what I'm going to do. Each of these represent 500, right? I got 1, 2, 3, 4, 5, 6, 7, 8. I would do this on my calculator. 8 times, how many does each one of these represent? 500. You do that in your head. 8 times 5 is 40. So 40 plus add the zeros. There's $4,000 a month. I mean, there's I'm sorry, I shouldn't put this in front of it. There's 4,000 hot dogs. Okay, there are eight of these, and each one represents 500. So 4,000 hot dogs got sold. But the question asked, it said, how much money? How much did the Hogan hot dog stand earn? They want to know how much they earned. Well, if each one is $1.85, I'm going to go 1.85 times in my calculator times 4,000, and that will give me the answer. And that's how I would figure that one out. Okay. Which number was that? I said that was number 40, and the answer would be $7,400. Okay. So that would give me 7,400. So they made $7,400 selling hot dogs. Not bad for a hot dog stand, right? If you've ever seen the movie While You Were Sleeping with Sandra Bullock, it's a great movie to watch over the holidays. But she's always meeting at this hot dog stand with her boss. So if you've ever seen it, you know what I'm talking about. It's fun. And by the way, if you've never seen that movie While You Were Sleeping, it's a comedy. Yeah, you got to see that movie. Write it down. While You Were Sleeping. I'm telling you, you're gonna love it. All right, so this is a funny looking chart here, and I have to apologize for it. I would have never put this, but the other teachers on campus put this one together, and so it's a little bit unclear, but I'm gonna explain what it means, okay? Because I think you have one question like this on the test. Let me see if I can find it. Yeah, here we go. Let me show it to you. Yeah, it's this one right here, 43 here. from figure 3. Again, I'm kind of modeling for you. Figure 3, what are they talking about? Oh, it's figure 3 here. This is the third graph, okay? So from figure 3, Olana earns $1.67 for each mile that she travels. If she traveled from Spokane to Everett, and then from Everett to Tacoma, and then to Yakima, how much does she get paid for mileage total? Okay. So I don't know if you guys have ever had a job where if you drove your car, they paid you so much money per mile, reimbursed you or something like that. Okay, it happens in some jobs. I used to have a job teaching online school, and when we drove to Olympia for our all-day trainings, they would reimburse us for our mileage and stuff. So anyway, so it says that she makes $1.67 for each mile. I'm going to circle this. I'm modeling this for you again. That's how much she makes per mile. Okay, let's look at so she goes from Spokane to Everett, S to E. So I'm going to write S to E, and then she goes, I'm writing it over here. Let's see, I'm going to write this down. Everett to Tacoma, E to T, Tacoma, and then she goes, and then to Yakima. So it would be from Tacoma to Yakima. Okay, those are the places. Okay, so first one is from Spokane to Everett. So here's how to interpret this chart. I warned you, this is kind of confusing. Okay, do you see? So it starts and says that she traveled from Spokane and went to Everett. What you do is, this is your start point, and if you have this, you do have it in front of you. You could have it in front of you. That's your starting. You're starting. See, it's under Spokane. The blank one is the starting point. Okay. So if you start in Spokane and you drive to Everett, all right, I'm starting. I went to the blank one. See how these are all going to be the blank ones? I'll write this here just to remind you that that's the idea. If I start in Tacoma, that's where I would be starting from. If I started in Yakima, I would be starting from here. And then the other ones are the same. All right. So if I start in Spokane and I go to Everett, well, let's go to Everett. From here to Everett, it's 315 miles. And again, this chart is crazy. I would never, it's just confusing. But if I start here, I go to Everett, what's the number? It's 315. Then it said, she went from Everett to Tacoma. So here's what you do. You go to the Everett one and you start here. I know this seems kind of crazy, but that's how you read this, okay? And you go from this Everett to Tacoma. How many miles is that? 62. That's how you would read this. And then she went from Tacoma to Yakima. I go to Tacoma. I go to my starting point. I go to Yakima. It's 156. I'm going to add all these up. 11, 12, 13. 8 plus 5, 9, 10, 11, 12, 13. So that's 3, 4, that's 533 total miles, okay? So if you're writing this down, there we go. There's my 533 total miles, okay? But the question asks, how much money does she get back? Well, she makes back, what did we say here? Did we write it down somewhere? I didn't write it down. $1.67. So if I take that 1.67, okay, and I multiply it, I will get an answer, okay? So it'll be 533 total miles times $1.06. This is $1.67, and I'll get a total. And that total, just to let you know, for number 43 the answer would be $890.11. 890.11. Whoa, that seems like, wait a second, is that right? That's number 43. That's the one we're doing. That seems like a lot of money. Anyway, that can't be right. Something's screwy there. But that is the answer that they have down here. That doesn't seem right. I don't think that answer is right. I think the answer people screwed it up. That just can't be right. So anyway, there you go. You would multiply 533 times 1.67. You'll get something different. Okay, it would not be 800 and some dollars. That's too much money to get back for that much driving. Wish I got that much back. Okay. All right. Let's go on to like the last kind of problem here. Okay. Yeah, let's go to number 47 here. Yeah, that's a good one to do. This is like the last kind of question on your problem, on your test, okay? It says to use the compound interest table. So it wants me to use this interest table that we're looking at. I'll show it to you, what it looks like. It's a table that looks, you're gonna have a table that looks like this, that shows, look at this, compound interest, okay? See, it's the compound interest table there at the top, okay? All right, so it says, number 47 says, use that table if Gente invests $9,000. Now I'm going to circle this because there's a reason why that's really important. $9,000 at an interest rate of 3% for 11 years. How much will her investment be worth at the end of the period? Okay. Again, I want you to notice that I am underlining, circling, highlighting things. This is very good test taking advice. If you can do this, okay? Now, if you're doing an online test like you will be, I would write things down on scratch paper. $9,000, and I would write it down, 9,000, okay? She's investing 9,000, and she's doing it for 3%, and I'd write that on my paper, and it's for 11 years, okay? I'd write these things down, okay, on my own paper if I was doing this on an online exam. So, all right, so it's she's investing 3% here, okay? $9,000 at a rate of 3% for 11 years. How much does she have at the end? Gente. All right, I'm gonna go and look at my charts here. Now you're gonna have this, so look at this chart and watch me carefully. The first chart here, I have here on the, is for 2.5%. The next chart is for 3%. The next chart is 3.5%. The next one is 4%. Oh, but it said 3%. This is the chart I want right here. This is the chart that's dealing with 3%. I'm going to go a little closer here so you can see that a little bit better. Okay. Now, in my notes that I just told you to take, remember I said, hey, write some notes down. It said she invested $9,000 for 3% for 11 years. All right, this is where it's a little bit tricky. I want you to really focus in. This is like the last thing I need to tell you tonight, okay? I want you to look at the chart. Look at this chart. It says at a 3%, if you invested $1,000, this is really important, guys. If I invested only $1,000, okay, for 11 years, I'm gonna go down here to this 11 here, okay, I would make $40.32. So at the end of 11 years, I would have this amount right here, $1,384.23. This amount, this is how much I would have after 11 years. Now listen to this very carefully. After 11 years at 3%. But if a person only invested $1,000, just 1,000, I would have this much money at the end. In my notes that I paid close attention because my teacher said, be sure to write this stuff down. It said Gente, invested $9,000. Oh, what would I do? I would take this answer here because this is only $1,000. I would take and go 9 times this amount right here on my calculator. I would go 9 times 1,384.23, and I'd get an answer. That is how much Gente would have at the end of 11 years. Okay. Let's say that they said, what if the person invested, $3,000 at 4.5%? I'm going to look down my charts and I go, oh, Here's the chart that says 4.5%. It was $3,000. I'm gonna write this 3 times this amount, okay? For, what did I say? 4 years, okay? So I'm dealing with this number right here. After 4 years, if I invested only $1,000, I would have 1,192 and 52 cents. But I invested $3,000, so it'd be 3 times this amount. Okay? All right. That is everything that's on the exam. That's every type of problem that is on your exam. So what I'm going to do is I'm going to turn this off, and I'm going to talk to you about a couple things. Just make sure you're all on the right page here, okay? Unpin video. Oh, let me turn off my recording here to stop.